All right, class.
Yes.
Need notes? Uh, here they are. Anyway, all right, so we're going to go through and we're going to do slope of a curve. And if you watched yesterday's video, this is what I did. What I did when I went through and actually talked about like the different things that we're due as we're taking the limit and then approaching zero with that value. So find the tangent of a curve, y equals fx at a point. Okay, I don't like the way that they put it as p, a. I hate all this. I hate the way that they describe it, and so like I said, today is off script. This is what I drew for you guys the other day. Because we are finding as h approaches 0, right? We had a secant line where the secant line touches my curve at two different points, right? It crosses my curve at 2 points. A tangent line will touch it at a single point. And I'm trying to get this h value to be 0. I'm trying to get it to like shrink all the way down to be 0. So from the notes that we did yesterday, it's the same thing. And they just called it, instead of the f of x plus h, they called it the a's. So my slope, same thing, limit as,
Why is it shaking?
because someone's upstairs, doing a dance class or something. As h approaches 0, we're gonna have and I proved this one yesterday when we went through by going through and using my slope formula and finding my values all the way through. So the tangent line to the curve point P passes through point P with the slope. So it's the same thing that we did yesterday. Slope of curve, all of the following mean the same thing. The slope of y equals f of x at x equals a, so that means it's going to be at that point. The slope of a tangent line to y equals f of x at x equals a. The instantaneous rate of change, that means at that instant, the rate of change. So we had Denny, he is driving 45 miles an hour through the crossing, the kids crossing, okay? What was the instantaneous, his acceleration? Okay, he was going pretty fast, right? So, what was his rate of change as he hit that first kindergarten? Okay, because he's going to slow down after each one because it's kind of like a speed bump. But as he's going, it's the instantaneous when he hits that kindergarten. That's what we're looking for, because he wasn't doing 45 miles an hour the whole time. He started at 20, he ended at 45 miles an hour. So somewhere in between, whereas is the rate of change that we're talking about. Danny, you good? You work last night? Like you're trying to fall asleep. You're like, no, fight it. All right. And the limit as h approaches 0 of my slope formula there, and expression right here is the difference quotient of f at a. All of it is basically finding the slope. Calculus 1. It's almost everything is finding the slope. Yeah. Normal curve. Okay, we said that a tangent curve touches it at a single point. A normal is perpendicular to the tangent. Okay, so perpendicular, my slope are opposite and reciprocal. Opposite and reciprocal. And my penmanship is horrible. So that's why I'm reading it out to you, because my penmanship is terrible. I apologize for that. I blame my kindergarten teacher. Huh? Robinson.
No problem.
We had those little drawing things. Like the line tracing things. But it was that really, yeah, and it was that really crappy paper too that would like leave splinters in your hand. Yeah. So, anyway. Now, slope of the normal line is negative reciprocal of the slope of the tangent line, opposite and reciprocal. Okay, example, normal to a curve. Given this, write the equation of the normal line, draw a graph of the curve, the tangent line, and the normal line in the same viewing window. Okay, so first, we have the equation. Now we need to find the equation of the normal line and the tangent line. So let's go ahead, and if this is going to be like my f of x, I'm going to do f of x plus h minus f of x over h as the limit as h approaches 0. Plug that in using that equation, and x at -1. X equals -1. So you're going to have to do some expanding. So h equals and expand. Okay, do you know what x is? Struggling to get started? Yeah. So, you're struggling here. F of x plus h. So everywhere that there's an x in this problem, I'm going to put x plus h. So my top one is going to be, let's see, parentheses, x plus h, close squared, plus 2 minus this side, which is f of -1. Oh, crap. I need to add it. My x is -1. And then my other one is parentheses -1 squared plus 2. All this is going to be over h. Hmm? This is your first one. Every place that you have an x value, you're going to replace it with. That's going to go right there. X plus h squared. That was my x value. Just like this x value is -1. No?
The thing that throws me off is that f of x, because I put it as y, so I just think that x squared.
So now I'm going to expand this one. Now we're going to expand using that trick I showed you guys yesterday. So instead of foiling this all out, what would I rewrite this one as? I gave you guys the formula on that one yesterday.
So a squared plus 2ab.
Plus b squared, right?
Yeah, b
So a squared. What is a in this value?
-1.
-1 squared is
1.
1. Okay. And your middle term is
2ab
plus 2ab.
plus 2a.
Plus 2ab. So now a times b is
-1h.
-h, right?
Oh, -h.
Times 2
2 -h.
minus 2h. And then plus b squared.
So h squared plus h squared.
All right. So that takes care of this piece right here. Bring down my plus 2. All right, so let's look at the second half over here. So it's going to be minus whatever my value is over here. Whatever my value is over here. So that's going to be a -1 squared, which is plus 2.
3.
So minus a 3, and everything is going to be over h, right? All right, let's combine. Let's combine. So leading coefficient would be what? Yeah, the square, right? So it's h squared minus 2h. And let's see, what's our constants? Plus 1, plus 2, minus 3.
0.
0, so that goes away now, right?
Yes.
And all this here is over
H.
going to cancel, but I'm going to factor it out first so I could show this one. So I'm going to take an h out of the top. H quantity, h minus 2 over h. And now can I take the limit as h approaches 0?
Yes.
So now I could plug in 0 for h. If I plug in 0 for h, my answer is -2. So now, what does that mean back in my original problem? Nope. We use a limit to find this value. What does that mean? It is the slope.
So you do the point.
No, not yet, not yet. So, the slope of my curve, because these are curves, the slope of my curve when x is -1 is -2. The slope of my curve when x equals is, okay, so you ready? So I'm gonna go to a graph now. No,
Just slow.
so. So, my line is +2, right?
Yeah.
Okay. There's a graph of it. Yes?
Yes.
All right, so same thing goes on this side. Now, let's go back. When x is -1, -1 right here, x is -1, the slope of the line at this point is, the slope of the line at that point is,
Negative.
very good. So the slope of the tangent line, because the tangent line touches it at a single point, is
Negative 2.
-2. Okay, so now let's find the equation of the tangent. So if I know that the slope -2, and what's my point going to be? What is going to be the coordinate? I know my x value is
Negative 1.
-1, but what's the y value going to be? How would I find the y value?
Um,
No, not yet, because I still got to find the point. Nope. Can't just start throwing stuff out there. How would you find the y value if you know the x? How would I find the y value if I know the x?
the given y equals.
It's kind of the given. It's not given though. Solve for y. Can I plug in the x?
Yeah.
Yeah, that's all you got to do. So it's not given to you. You have to solve for it. By plugging in your x value, we got to find the y value. So by doing that, it is y equals -1 squared plus 2. So y equals 3. So my point, now I have the point and now I have a slope. So now I can find the equation of the tangent line. So it's going to be y, what's the equation? Which is -3 equals, parentheses, x minus x1, right? Which is going to be minus a -1, which is going to make that a
Positive 1.
+1, close. So, knowing the point slope formula is going to make this a whole lot easier for you to plug in a lot of your answers. So I could rewrite this answer if I had to by rewriting it as a y equals a -2 quantity x minus 1 plus 3. if I needed to write it as a y equals. Calculus in the AP test is actually, you don't have to simplify anything. You don't have to distribute. This answer is correct. You don't have to distribute. Alrighty. Yes, no, maybe? Alrighty. Now, given this, let's go back. This is the tangent. So we got the curve, we got the tangent, now we need the normal. What do we know about the normal? What do you know about the normal?
Define normal.
Okay, so what is it?
Perpendicular
Perpendicular to the tangent, right?
to the tangent.
Okay. So do I have a point?
Yes.
Yes. Now, if it's perpendicular to a tangent, do I now have the slope?
Yes.
What's my slope going to be? What's the slope going to be?
The current slope of the blue one?
No, of the normal.
Of the normal.
Positive 1/2, very good. Where did we get that one from? Because it has to be perpendicular, which is opposite reciprocal to this. If this is the tangent, perpendicular to that is going to be opposite reciprocal. So it started with the negative and it has to be positive. This is 2/1 technically, and flip that over to make it a reciprocal, so it's now a positive 1/2. Now, what point am I going to use? Same point. Same point because it's perpendicular to this one. So it has to be the same point. So my point is going to be -1, 3. So it is perpendicular. I'm going to put a little box right there to show that that is creating a 90-degree angle to my tangent. And my equation? Write out your equation. What's the equation for this one going to be? Anyone?
Y equals.
I don't like it. Y. Use your point slope formula. -3 equals 1/2. There you go. Make sense or nonsense? Kinda? So from here, let's take a look what we got coming up. But before I do this one, I'm going to pause this one now. All right, so we're going to finish this up. So now this is another way of actually reading this. We're doing this because this is now velocity. Velocity is actually majority of what we do in this class. Because we have a couple things that we talk about. If I have a graph, this is my distance, and this is my time. So, distance over time is going to give me my position. Okay, so if I travel for 2 seconds, I'm getting a gradual distance in between here, right? So back to Denny driving 45 miles an hour through that school zone, his distance over time. But he is not doing 45 miles an hour the whole time, because he starts at 0 when the red light turns green. Okay, so that means that he's accelerating. So his slope should look something like this, going up. So he's going faster, getting to a certain point. So he's increasing in speed. So distance over time. So velocity is going to be the speed at a certain point, the rate of change at that point. So I have a distance over time is going to give me my position, and then the slope of the position right here is going to be my velocity. Make sense or no? This one right here is no. Denny driving. So here's Denny's car. So you got a hatchback, Denny? No? Okay, so Denny has that 84 Honda Civic. Okay, so it's Denny driving. So he's driving, and so as he drives, he's just going faster and faster and faster, right? Until he finally gets to that crosswalk where those little kids, just so you know, little kids can be a-holes, just so you know. I don't know why. They look at you with those dead eyes sometimes, and they just say like, dang, what's wrong with you? Seriously, man. All right, anyway, so as we're speeding up to this point, so my distance over time is going to give me my position. So Denny, for 45 miles an hour, if he travels for 2 hours, his position should be 90 miles away, right? If he's doing 45 miles per hour after 2 hours, that's going to give me my position. Distance over time. Yes? He should be 90 miles away if he's going 45 miles an hour the whole time. Yes? Meow meow? You zone it out again. Or are you just enthralled by Denny's car? Huh? Without the bumper. But Denny has bumpers. Okay, he hasn't hit anything yet. Alright, so now the rate of change, because he is not actually going 45 the whole time. He's increasing to get to a point. And our rate of change right there is going to be his velocity. So, instantaneous velocity at any time t, instantaneous rate of change, position, respect to time, or the limit as h approaches 0. Now this time instead of f of x, it's f of t, because we're going to be dealing with functions in terms of time. A lot of these are going to be in terms of time. Everything that we talk about, position, distance, velocity, acceleration, is going to be in time. And sensitivity. Okay, so we live in an interconnected world where changes in one quantity cause changes in another. For example, crop yields per acre depend on rainfall. Rainfall has been low. Each small increase in the amount of rain creates a small increase in the crop yield. For a drug that works to lower a patient's temperature, each small increase in the amount of the drug will lower the temperature a small amount. Sensitivity. Mathematical connected between such changes known as sensitivity. Sensitivity describes how one variable responds to small changes in another variable. If we denote T as a patient's temperature, the D, the dosage, then the sensitivity is given by, delta T So that's the change in temperature over the change in drugs. That's what that means. And I'm trying to get that as close to 0 as possible, because when I looked at my graph, I could see I want it to be closer to 0 so I could find an instantaneous point. Right now, this is just going to be the limit as that in between 2 points, where we're eventually trying to get to the point of being the slope at any given point. Yes, temp. It's abbreviation for temperature.
What's this?
What? Change in drugs. D, dosage of the drug. And guess what? That's it. Now, so the problem in the homework, we have two different things. I'm gonna like, share, and subscribe right here.